let's get on. My name's Gemma Monk-Hartley. I'm from Herefordshire Green Network's Building Sense group. We were an initiative that was started in 2020 to bring together people, information and professional expertise to help with the challenge of making homes more comfortable year round in the face of high heating bills and cutting carbon emissions. Today, we're delighted to be hosting Paul Sheridan, who is the Senior Home Energy Specialist at Severn Wye Energy Agency on behalf of the Future Ready Homes programme. Future Ready Homes is running in Shropshire, Powys and Herefordshire. It's been delivered by two energy agencies, Marches Energy Agency in Shropshire and Severn Wye Energy Agency in Herefordshire. And it's being supported by groups such as us, HGN in Herefordshire, Lightfoot in Powys and Zero Carbon Shropshire in Shropshire. The main focus of the Future Ready Homes programme is to promote and support good practice energy retrofit of homes across the whole Marches area. They're doing this through a webinar series, why we're here today, retrofit advice and green doors, which is taking place imminently in October. And I will tell you a bit more about that after this presentation. Right, so let me introduce you to our speaker. Paul Sheridan has been working at Severn Wye as a domestic energy advisor since 2004 on a whole range of energy efficiency and renewable energy projects. He's got over 25 years experience on energy efficiency and renewable energy technologies through personal interest and volunteering with renewable energy charities. Paul's qualified as a domestic energy assessor and an accredited retrofit assessor as well. He's got qualifications in energy efficiency measures for older and traditional buildings, which is always of interest and use. Today, Paul is going to help us prepare for winter with low cost and no cost measures, behaviour changes, all of the above, that will help us to keep our energy bills down and help us to stay warmer as well. So Paul, thank you very much for joining us. Can you please take over sharing your screen?
Okay, thanks for that, Gemma. I will just let's change the screen now to mine. Right, so hopefully everybody can now see my screen. So yeah, what we're going to, okay. So a quick summary, these are the four things I'm going to be having a quick look through today. So we're going to look at energy bills, a bit about fabric. This will be looking at the lower cost measures to do with fabric, heating systems, and a bit of behaviour, make the most of the energy that you do use. So starting off with fuel bills, I see gas and electricity bills, but some of you are probably on oil or other sorts of heat or LPG maybe. But the important thing is to understand your bill, is to look at the bills, make sure that you can see what tariff you're on, whether it's a fixed tariff, what the rates are, check if the bill is actually an accurate representation of your usage or if it's an estimated. If it's an estimated bill that they've sent you, it's always worth going and look at your meter readings to see whether their estimate is very accurate, because you could find that you're going way out of built on either above or below what they're estimating, and then that either means that you're paying too much or you're going to get a big bill once they sort things out. So if you have got an estimated bill, sending in the readings and then get them to give you a new bill which is more accurate. And if you know when your bill's about to arrive, maybe send the readings in or phone the readings in just beforehand to make sure that your bill is as accurate as possible. And always check what tariff you're on and whether they've got any better ones for you. There are not many fixed tariffs around at the moment because of the price situation, but some companies are now starting to offer them again. Another way of getting the most out of it is to get a smart meter. Now, The energy company will install that for free in your home, and then that gives you, to start with, it gives you accurate bills, because when they come to prepare your bill, they will read your meter, so the bill will always be accurate. There will be no more of those estimates coming through which you have to double check on. You will get an in-house display unit which shows you what you're using, and that can help you to understand what's being used in the house at the moment, what you used over today, what you used yesterday, last week, last month, and help you to get a better grip on when and where the energy is being used in your home, whether it's the gas or electricity. You can get smart systems for oil now. It might be worth talking to your energy company about that, or your oil supplier. But for standard gas and electricity people, the electricity can show you what you're actually using at the moment. The gas side of it is done on a half hourly. It only updates every half an hour, so it's not as live. And then if you're on one of these smart tariffs, you may be able to go online and log into your energy suppliers either through an app or logging into their website, and then that can give you more information about your energy usage there. The other advantage of having a smart meter is that it opens up the ability to get access to what they call time of use tariffs. Now, the traditional time of use tariff was an economy 7, so you pay one price at night and one price during the day. Now, with the smart meters, they can set different tariffs at different times of the day. They tend to be for a specific purpose. So you might have a tariff with a cheap rate because you've got an electric vehicle. It might be because you've got solar panels and a battery, or it might be because you've got a heat pump. And all these different things that they can offer you, these tariffs which have cheaper rates at certain points of the time of the day, but maybe higher rates at others. And it's not necessarily just cheaper overnight now, it might be cheaper in periods during the day as well. So if it works for you, then that might be a way of helping you to get your costs down. And obviously, it's not going to suit everybody. And if you have got one of these, you want to try and make the most of it. But it's a potential way of looking at getting the costs down in the future, especially as we go towards the electrification of everything. So moving on to simple fabric savings, making sure your windows and doors don't have any leaks around them. If you feel drafts coming through or around the doors and windows, then quite often it's simple draft proofing. There may be seals on the windows already, especially if the windows are relatively new, they will have draft proofing in them already. If you've got very old single glazed metal frame windows, then unfortunately you can't actually draft proof those, but maybe look at some sort of secondary glazing. And if you've got sash windows, one of the best things you can do for them, even if they are single glazed, is to have them draft proofed. It normally entails taking the sash out and putting a rebate around it, putting brush strips in and then putting them back in again. But it can make a huge difference to the energy efficiency of those windows. If you've got an energy performance certificate for your building, have a look at the recommendations and see what things there are recommended to save you money. A lot of those will be potentially major items, but it might be something that if you're thinking of redecorating or refurbishing, you might be able to incorporate some of those measures into improving the rating of the property. And anything you do to improve the efficiency of the property is obviously going to have an effect on reducing your fuel bills. because you won't need as much energy to keep at the same temperature. Loft insulation is one of those easy things. It can potentially be done as a DIY job, or you can get people in. A lot of lofts may only have 100 mil or 150 millimeters of loft depth. So if you look in your loft and the insulation's no higher than the joists, then it's recommended you top it up. The current recommended depth is around 400 millimeters. If you've got 250 millimeters or thereabouts, 250, 300, then the extra 100 millimeters will have a very low return because you've already got 250 mil of insulation there, so there's not much heat getting through that. If you've only got 100 mil and it's between the joists, then you can make quite a saving by increasing that to a higher level. And when you increase the thickness of the insulation, the next layer of insulation is rolled out at 90 degrees to the joists so that it covers them up and all the on any gaps that are between the joists and the insulation of the layer between them. So it does mean that once that's done, then the loft is just a sea of insulation and you don't know where the joists are anymore. If you want to use it for storage, you can get little pillars from DIY shops quite cheaply that you screw onto the joists, and then you can put your flooring on top of those, which still allows you to have at least 300 mil of insulation typically, which will be a good value. But if you do want to use it for storage, then obviously you only need to do the flooring for the bit that you actually want to use. You don't need to floor the whole loft out. It might be that you've got, some people have their boiler in the loft or a hot water tank up there or whatever, and you might need a bit of a walkway, but you can raise that up to give you more insulation. Another quick win for a property is cavity wall insulation. If it was built since probably then the 1930s, it will have a cavity construction. Some properties earlier than that will have had it as well, and some later on might not. But you can usually tell if you've got an energy performance certificate, it will say what sort of walls you've got and whether they think it's been insulated or not. If you can see the brick pattern on the outside and all you can see is the long sides of all the bricks, then it probably is a cavity. But you can get a free survey from a cavity insulation company and they will tell you whether the cavity is suitable for filling. And not all cavities are actually suitable for filling. There might be some issues in the cavity, or you might be in a very exposed area, which they don't recommend it actually being filled. As I say, you can get a free survey from them and then they will be able to give you guidance on whether it can be filled or not. If it can be, then that can make quite a big improvement. And there are some grants around to help with the cost of that. If you've got a suspended floor, making sure that there's no drafts coming up between the floorboards, because that's going to create a cold space at the ground, especially in the winter when you've got cold air flowing under the building. It's important that the air flows under the building so that the floor doesn't get damp and start to rot. You need the ventilation. What you don't want is that ventilation coming up between the boards and cooling you down. If you've got the flooring covered with a carpet, make sure there's a good underlay under there, or even a thin layer of insulation to separate it away. And make sure all your light bulbs throughout the house now are pretty much LED. They are even more efficient than the old compact fluorescents that a lot of people didn't like because they had the cages to warm up, and a lot of people didn't like the look of them. But they're pretty much all shops only sell LED lighting now. So if you've got any old bulbs that you don't use or you haven't got around to changing because you're waiting for them to blow, I would just get on and change them, because the saving from changing it to an LED will be quite quick. It's generally a period of months if it's in a room that's generally used, especially if you've got a lot of downlighters. So for example, if you've got 10 downlighters in a room, traditionally they would have been halogen bulbs at about 50 watts each. So if you've got 10 of them, that's 500 watts of lighting you've got going on there. If you change them to LEDs, each one will be about 5 watts. So suddenly your 500 watts of energy usage becomes 50 watts. And obviously that will have a knock-on effect onto your fuel bill, because during the winter periods we have the lighting on a lot more. And as we get into the cooler weather, no matter what sort of heating system you've got, making sure that you understand the heating controls is quite important to making the best use of them and helping to keep the fuel bills under control. And also, it varies with every house. So every house is different. So there's no set way we can say of how to use a heating system in a property. You know your house, the one that you live in, how long it takes to warm up, how quickly it cools down, what sort of temperature you want it to be and when you want it to be. And so you're looking at standard controls would be either a programmer and a thermostat mounted on the wall somewhere, although increasingly they're wireless, so you can move them around. Ideally, the room stat would be in one of the cooler rooms of the house, because if you put it in the warmer room, obviously it's going to turn off quicker, depending on what temperature you got it set at, and then the rest of the heating will go off for the whole of the rest of the house. A lot of the modern systems come with what's known as a programmable thermostat, so that the heating and the thermostat are built into the same unit. What that means is technically the heating is always on. It only actually fires up when it gets below the target you've set it. So you could say, for example, 6:30 in the morning, I want the house 20 degrees. At 8 o'clock, when we're all gone out, it can drop back to 18. And then in the evening, I want it to come back up to 20 at 4 o'clock. And then maybe at 10 o'clock in the evening, it drops down to 16 overnight, and then comes back around again. So it will never allow the place to get too cold. Whereas the traditional programmer and separate room thermostat, when the programmer turned off, the heating was off no matter how cold the building got. You can get thermostatic valves on each of the radiators, which allow you to set some rooms to be slightly warmer than others. Ideally, you wouldn't turn the thermostat right off in any of the rooms, because if one of the rooms gets quite chilly, then it will take heat from the rest of the house. And there's a potential there that warm, moist air going into a cold room could lead to condensation and issues on the walls. So ideally, you'd have the thermostatic valve set up low in the rooms that you don't use much and higher in the ones that you do use. But the idea of them is not to keep changing them. You would set the thermostatic radiator valve up to a set temperature and then possibly just leave it there once you've got the idea of it. There are more and more smart heating control systems out there, things like Hive and Tado and other companies that are bringing out stuff that you can control from your phone or from a tablet. They're basically a more high-tech version of those, and you can get them with programmable radiator thermostats, programmable, or just for the whole house. And as far as boilers go, any gas boiler fitted since 2005 would be a condensing boiler. And you can now, the oil boilers and LPG boilers are also coming condensing boilers, which means that they are a bit more efficient than the traditional boilers, but only if they're run correctly. So we're looking at this, what we call the boiler flow temperature. Now, this is not the temperature that the room thermostat is set to achieve. It's the temperature of the water that's flowing through the radiators. So obviously, as you turn this down, your radiators won't get as hot, but they can run more efficiently. So a nominal boiler, which is given an efficiency of 92%, if it's run at a high flow temperature, so that the water returning back to the boiler is greater than 55 degrees, then it will possibly be losing 10 or 12% of its efficiency and might only be running at 82% efficient instead of 92%. But turning the temperature down so your radiators aren't quite as hot may make the boiler much more efficient, which in turn means it burns less gas to give you that same amount of heating. The only thing is, if the boiler is running less hot, you may need to extend the times that you have the radiators on, because they will take that little bit longer to heat up, which might seem counterintuitive, having the heating on for longer, but having it on for longer at a lower temperature is actually more efficient and burns less gas than having it on higher for a shorter period of time. And I like to think an analogy for that would be, for example, if you were going to the shops and you were going to drive 5 miles up the road, if you drove at 90 miles an hour, you get there really quickly, but the MPG of your vehicle would be very poor. Whereas if you drove at 20 miles an hour, it would take a lot longer to get there. You get a much better MPG out of it. So the same applies with the heating system. If you can reduce the temperature down, then it will be more efficient. But be careful if your boiler has a hot water cylinder attached to it. So all that really applies to combis. If you've got an ordinary a standard boiler with a hot water cylinder, then if you turn it down to 55 degrees, the water in your cylinder will never get above maybe 5 degrees cooler than that. So you might want to think about not putting it down quite so far with a standard boiler, or boosting the temperature of your water maybe once a week to make sure that there's no risk of Legionella forming inside the cylinder. But for a combi boiler, there's no water storage generally, so it doesn't matter if you run it at a lower temperature. And also you have the ability with a combi to set the temperature of the heating and the flow temperature of the hot water separately. So here's a couple of examples of some boiler controls. Now, if you've got a combi, you will have one control will have a picture of a tap and one will have a picture of a radiator near to it. If you've got a digital display on the boiler, it will show you what temperatures you're setting them to. If you haven't got a digital display like the one on the bottom right, it's just a case of trial and error to see how it affects your bills. You can try experimenting. When the weather cools down, you can turn the temperature down and maybe extend the times, and keeping an eye on the gas meter reading at the beginning and the end of, say, a week's period, and then change the temperatures and do it again over another week's period, and see what effect that has on your fuel bill, assuming that both weeks are roughly the same sort of temperature wise. You can tell if you've got a condensing boiler, if you can see it, because there will be a white plastic pipe coming out of the bottom of the boiler. which is the condensate pipe, which can be clearly seen in the photo on the left there. And if the boiler's been installed in roughly the last 18 years, it probably is a condensing boiler. Although I know there are some boilers out there that are a lot older than that and they're still going. But understanding your boiler controls can be a way of reducing your fuel bill without changing the comfort level or spending any money. Just by adjusting the temperatures down can help to make a difference there. Other things, if you have got a hot water cylinder, typically the pipe work around the cylinder will look like the one on the left. So you've got a reasonably insulated cylinder there, probably got quite a thick jacket on it. It's got a thermostat on it. But the hottest point of the cylinder is the top of it. And at the top, that pipe coming out the top is radiating heat, which means that you've spent money heating the water up, and now that water is cooling down, even though you're not using it. It means that you might have a really warm airing cupboard, but even if you insulate the pipework, you'll still have some heat leaking. There will always be a bit of heat loss from a cylinder, and you could have a warm airing cupboard instead of a hot airing cupboard. So on the right-hand side is a photo of the pipework that's now been insulated. So they've just insulated the hot pipe from the top of the cylinder pretty much. That can make it can make a noticeable difference to the amount of hot water or money that you spend generating hot water. Obviously depends on your hot water usage. If you're heating it up and using it quite quickly and getting through that water, then the savings are potentially going to be a bit less than if you heat it up overnight on the cheap rate and then it sits there till you have a bath in the evening. Then the water will have cooled down during the daytime, especially in the winter when the house will be a bit cooler as well. If you've got an older hot water cylinder which has still got one of these red jackets on, make sure there's no gaps between the strips of the fabric. If there's only got one layer of the jacket on it, maybe go down the DIY shop and buy another one, about a tenner, and put it over the top so that the next layer you put over so it straddles the gaps on the layer below to make sure that there's no more heat loss going. And again, insulate the bit of pipework out of the top. If you've got a cylinder thermostat that's visible, check what that's set to. It doesn't need to be much hotter than, say, 55 degrees. The thermostats probably are not that accurate because they're only resting on the outside of the cylinder. So they're measuring the temperature of the skin of the cylinder itself rather than the temperature of the water inside it. So it's probably going to be a little bit cooler on there than it is in the middle of the cylinder. Some of the more modern cylinder stats actually have a probe which goes into the cylinder itself, which gives you a bit more accurate result. But if it's set at 60 or above, well, above 60, I'd bring it back down there. It usually just a little dial that you can, with an arrow on it, and you just change that back round to get the right settings. When radiators are traditionally under windows, so when you pull the curtains in the evening, make sure that you don't cover up the radiator, because otherwise any heat from that radiator is just being directed into the window and is not really benefiting you in the room. The picture on the right shows a bay window, and what they've done is they've just tucked the curtains into the bay in the evening. They let them hang down during the day, and then in the evening when it goes dark and you want to pull the curtains, just tuck them up into the window so that the radiator is not covered up. Don't put any furniture in front of radiators if you can help it. If the only place you can put your sofa is in front of the radiator because it's not under a window, it's on one of the walls, then make sure there's a good few inches gap between the closest point of the sofa, which is usually at the top, and the radiator, just to allow for the air to circulate a bit better. If you can put reflective panels behind radiators if they're on external walls. Doesn't make any difference if they're on internal walls really, because all you're doing is warming up the wall behind, which will then re-radiate. But if it's on an external wall, that heat may be being lost. If you've got solid walls, that can make maybe 5% difference to your fuel bill if you do it on all the radiators. If you've got cavity filled walls or insulated walls, then the savings aren't going to be as big because the insulation of the wall is going to stop some of that heat from leaking. But they are quite cheap to buy a pack of, again, from the DIY shops, and you just slot them in behind the radiators. Another cheap way that might help to just boost the temperature in the room slightly. And then looking at things that you can do if you're going to have a cup of tea, put enough water in for how many cups you want. Because if you fill the kettle right up and boil 1.5 litres of water when you only want 1 cup, it will take a long time for the kettle to boil and use more energy. And there's probably a tendency for you to wander off and do something else whilst waiting for the kettle to boil. Then you'll come back 10 minutes later and it'll have cooled off and you put it back on again. So you'll have a double whammy there. If you've got LED lights, to make sure all the lights are turned off, even the LEDs and all other things that are not in use. So trying to minimize the amount of things you have on standby. If, for example, in the kitchen, you've got a microwave with a clock on it, the cooker's got a clock on it, you've got a clock on the wall, you've got a clock on your radio, turn some of these things off when you're not using them, because you don't need all those gadgets to be left on standby all the time. When you're charging up your phone, typically they only take an hour and a half to charge up. So if you stick it on charge all night, then the power plug will still be taking a small amount of energy, because you'll notice that plug is warm. And even when the phone's charged up, it will still be there. So maybe put it on for the last hour of the evening, or put it on for an hour in the morning, so that it's not being used all the time. If you're going to use something like the cooker, try and plan it a bit. Fill the cooker up with things if you can to make the most use of it. Washing machines, the lower the temperature cycle, the less energy it will consume. Washing machines and dishwashers nowadays are all cold fill. So the water is heated to the required temperature at point of use. So by lowering that temperature, you're reducing the amount of energy that's needed by that appliance. And things like washing machines, the majority of the energy is consumed in heating the water. When it's actually just spinning and tumbling, that the motor running the drum is probably only 100 watts or so. It's not taking very much power at all. In the winter, if you're hanging clothes on a clothes horse, put it in the bathroom, turn the extract fan on, so it's the moist air is being taken out of the house rather than filling the room with moist air. It's much cheaper than using a tumble dryer. If you're going to use a tumble dryer, maybe use it sparingly, just for some items rather than throwing everything in there. And if you have got a time of use tariff with a cheaper rate, if you are going to use the tumble dryer, do it on that cheaper rate if you can. So it doesn't consume less electricity, but it costs you less. So it'll add less to your bill in the long run. And don't cover radiators with wet clothes, because A, reduces the efficiency of the radiator because the heat can't get out of it very well. And it's just putting lots of moisture into the room. So you could end up with damp walls then, which can lead to all sorts of issues with the fabric of the building, not least mold and condensation appearing, which the mold is not good for your health either. So if you can, and it's a dry day, hang it outside if possible. If not, I'd say try and put it in a room. If you've got a utility room or the bathroom, and shut the door, get some ventilation on there so that the majority of the moisture is not coming into the house, because damp walls take a lot longer to warm up than the warm walls, dry walls would. If you're looking at buying new appliances, check on their energy rating. Now, the rating scale was revised a little while ago back down to the A to G scale. It was getting a bit out of hand, where it was going from A+++, because they had an A rated thing, and then somebody brought out a slightly better than A, so they had A+, and then an A++, and so on. So it just got very confusing, with A being in the middle of the range. So it's now been regraded to make it simple again. So we've got A to G. Something that was at A+++ has probably been downgraded to a D. So don't be off-put if you see things that are D or E in the shops. They've allowed in the scope plenty of room for improvements, so that they don't end up in the same problem as they had last time. If you've got an upright freezer, then every time you open the door to take something out of the freezer, some cold air will drop out. And then the warm air that's gone in its place has to then be cooled down, which will make the freezer work harder and potentially frost up in the freezer. So ideally, either keep the freezer fairly full of stuff, or if you haven't got much in the freezer at the moment, maybe some bags of bags or bubble wrap or something like, or just empty containers, just so that there's less air volume in there. It's more full of things than air, so when you open the door, not quite so much air falls out. If you have got renewables in your home, then if you've got solar electric PV panels, making use of the home generation when it's actually being generated, rather than selling it to the grid and then having to buy it back later. If you have got a hot water cylinder, for example, you can get a device which will automatically take all the excess that the house doesn't need and put it into the immersion to heat your water. And that potentially can give you most of your hot water through the summer months, which means that you don't have to pay anything to heat your water up. If you've got a solar thermal system, which is designed to heat the water in your hot water cylinder, make sure that the central heating doesn't come on and heat up the cylinder in the morning, because then the solar thermal will have very little to do, because the water is already hot. So if you've got one of those systems, to get the most out of it, you need the water to be fairly cool, first of all, and then the system on a sunny day will be able to heat it up. Obviously, neither of these will give you very much of an output in the middle of December, for example, when there's short cold days. But from spring through to autumn, they can be quite beneficial in the amount of energy that you can get out of them. And I think that's the end of the presentation. We have a booklet on the Warm and Well website, which gives 101 energy efficiency tips, which is worth having a look at if you can do that. And we had a brainstorm here and came up with 101 things. They're not always, probably not all applicable to your house, but they will be applicable to some people. So I'll hand back now to Gemma and
Thank you. Lovely. Thanks very much. 101, is that all? Yeah, we don't want to go through those line by line right now, but we'll make sure that we share the guide with everyone who's here after, so you can all have a look through at your leisure. Yeah, really interesting, and there's been lots of things coming up on the chat as well, and I'm sure it will continue to do so. So Tony, would you like to kick off?
Yes, we'll be doing the Q&A as usual. Paul, I hope you're ready for all sorts of, well, weird and wonderful questions. We've got a couple of comments about smart meters, useful things. Octopus have just given me a new interface with the smart meter, enabling access to better access their instant and half-hourly data via their app rather than going online. Imagine that's a good thing, makes life easier. Comment from Byron, just a couple of comments, Paul. Octopus Go tariff is a miserly 9p per kilowatt hours between, is it midnight and 4 in the morning, or half past?
Half 12 to half 4.
Yeah. So charging an EV with it, for instance, works very well. I think Gemma, I know, runs her dishwasher in the middle of the night to make the most of that. So that's handy. Right, I'd like to hear more about this way of draft-proofing sash windows. What have you got for draft-proofing sashes? Is that with brushes?
Yes. Yeah, if you take the sash out and rebate around it and then put a brush strip in there and then put it back in again, it draft proofs the sash window, and it also stops it stops it rattling when it's windy as well.
Ideal. Okay, so following on from that, that sounds a little bit technical. If you can't do that yourself, how do you get someone to do it? Jackie has asked similarly. Some of us don't like or don't want to go up in the loft and insulate the loft. So how do you find people to do these sort of, I mean, it's not really building work, is it? So how do you go about that?
And there's the national scheme. There's a Trustmark website that you can go on, and if you select loft insulation and put in where you are, they will come up with a list of people who cover your area.
Right. Okay.
And then as regards sash windows, there are sash window specialists that will do. If you did an online search, I'm sure you could find those.
Or would a carpenter be able to do it, do you think, or a joiner?
Yeah, probably. It's just a case of taking the sash out and rebating around it.
Yeah. Okay, so suspended floors. Helen, I don't think she wants to lift up her floorboards. Is a thermal carpet underlay available?
Yes, you can get thermal underlays to go under carpets. Most carpet fitters will be able to tell you about those. Or you can get specific products, floor insulation products that may be only 5 mil thick, which can go under the carpet.
Right, okay. I was going to ask a question. Actually, you may have covered it and I didn't pick it up, but you were talking about not running the gas boiler too hot so that it condenses properly and it's more efficient. Can you explain what that actually means? What is condensing? What is a condensing boiler? What is condensing? Right,
a condensing boiler. What you understand the concept of condensation? If a warm moist air hits a cold surface. Now, traditionally, boilers, the temperature of the gas coming out of the flue was quite high. With a condensing boiler, there's another heat exchanger in there, which grabs some of that heat so that the temperature coming out of the flue is much cooler, which is why with a condensing boiler, you can see the plume outside much more visibly because the air is the air coming out of the flume is cooler already, so it tends to. And by extracting some of that heat through this heat exchanger, obviously you get the process of condensation, which is what that white pipe is there to get rid of the condensate when it forms inside the boiler. And by running it at that lower temperature, the boiler automatically goes into this condensing mode. And that then gives you that extra efficiency because you are grabbing some of that heat. If the flow temperature is too hot, it doesn't go into the condensing mode. As it just throws it away as it traditionally did. So you're losing quite a bit of efficiency from your boiler because you're not grabbing that heat that would otherwise have been thrown away.
Good to know. Right. I think HGN did a webinar 18 months ago or so on exactly that, on using boilers more efficiently, which was worth looking for on YouTube if you want to find it. So a comment from Jackie: do you think that running your boiler at a low temperature and still being cozy is a good way to see how a heat pump might work in your home? I think that's a bit of a leading question, if I may say, from Jackie. Obviously, heat pumps, as we know, they tend to operate more efficiently about 45, 50 degree flow temperature. So if you wanted to test your radiators and your heat, your sort of thermal efficiency of your house, if you wanted to try it at a lower temperature, it would give you an indication of whether a heat pump is going to work for you. Is that I think you're supposed to say yes.
I'll just say yes. Yeah, so it would show whether the house is capable of running comfortably at that lower temperature. Obviously, remembering to extend the time period that you have the heating on. Ideally, if you're going down something like the heat pump route, you'd have the heating on fairly constantly, but at that lower temperature. And then the controls, you can get more sophisticated controls, which would then adjust the output from whether it's a heat pump or a modern condensing boiler. You can adjust the power output to maximize the efficiency. So it applies just as much to your standard gas boiler. But if it can run at that lower temperature comfortably, then you probably are pretty much there for a heat pump.
Yeah, I do. Okay. I was interested actually in the classic behavioural issues of furniture, sofas soaking up all the heat and curtains. Helen's asking, is there a recommended gap between the radiator and the sofa?
I would say you want to leave at least a few inches, or maybe sort of fifth in modern terms. I shouldn't speak in inches anymore, should I? You make 50, 75 mil. I would go with a minimum. If you can move the sofa maybe 100, 150 mil away from the radiator, that will be better. I know, depending on the size of the room and where the sofa is, some people don't want to move them too far away because there's not that much room in the first place. But ideally, it shouldn't ever be touching or within sort of 30, 50 mil of the radiator, because then all you're doing is heating up the back of the sofa.
Yeah,
and
absolutely.
you're not really heating the room.
Okay. What behavioral energy savings would you recommend for people who have solar PV at home? I think you sort of touched on this, using the power while it's being generated. Just a comment from Frank, if I may. We have a small travel kettle which is just 700 watts. Our solar panels do 2 kilowatts, 2000 watts, so we can run the kettle for free quite a lot of the time.
Yep, he's a man after my own heart. I've got a 1,000 kilowatt kettle from a caravan shop at home, which obviously it takes a little bit longer to boil, but it's quite often underneath the amount that the solar panels are generating, so it's not costing me anything to actually boil the kettle. So it's anything like that. If you've got solar panels, anything that you can do to make use of the power that's coming out of them. And if you've gone to the next level and got a battery as well, then you can take it to a whole nother level there by filling your battery up when the electricity that they're not actually using during the day and using it in the evening.
Okay, a few energy saving tips from Brian. When cooking, don't use the oven. Cover pots, saucepans on the hob. Use the microwave and eat salads. I wonder about that. I use the microwave quite a bit. Are they energy efficient? I should know the answer to that, but I don't.
Well, they run for much shorter times than the oven, and typically you'll find they're like 700 to 900 watts.
Yeah.
Hour, whereas your oven is probably 2.5, 3 kilowatts when it's heating up. But if you're doing lots of microwaves, are great if you're doing small amounts. So if you're cooking for one or cooking for two, maybe use it in the microwave. But if you're trying to do a meal for 4 people, you probably end up running the microwave for quite a long time because you're having to do it all in batches because it can't fit it all in there. And if you put more things in, it slows down the cooking. So cooking 1 jacket potato in a microwave is great.
Yeah.
Cooking half a dozen jacket potatoes, you'd be better off putting them in the oven by the time you've gone through the process of it, because they'll all come out at the same time. Whereas if you try and do them all in the microwave, it can take quite a long time. So
Okay.
it's doing it the right way. If there's 1 or 2 of you, then the microwave is great. If there's a whole family, the oven might be better, depending on what you're cooking.
Okay. Right. Question from Bridget. We've been told, we're back to smart meters here. We've been told that we can't have a smart meter because we have no mobile phone reception here. Is that true?
There are still some places where the energy companies are saying that smart meters are not able to be fitted. So unfortunately, yes, that is still true at the moment for certain areas, but it has improved a lot. If you applied a couple of years ago and were told that there was no signal, it might be worth trying again because things have improved, but there are still people who can't get it, unfortunately.
Okay. Righto. Right, we're on sash window upgrades. Very briefly, Jackie mentions there's a Herefordshire company that will do sash upgrades. Their work looked really nice when I saw it. So we will find out who that is and put a name to it when we email you after this event so that everybody's got that. I have got a name here for carpet underlay. Brian is suggesting insulating, draft proofing underlay, Charleston Cloud 9. He is recommending. I'm sure other carpet underlays are available on the market. Right, a question from Keith. I think there should be a stronger encouragement for use of outdoor washing lines in winter. Does a perfect job on most dry days. What is your view, please, on leaving a water heater with a well-insulated cylinder on continuously? So if the cylinder is well insulated, it should be holding its heat anyway. Would you leave it on continuously? I'm assuming he means an immersion.
Probably an immersion. I would say probably not. If the cylinder is well insulated and the pipe work around it is insulated, it will hold its heat for. It depends. Again, if you're heating it up overnight and you're not going to be using it till the next evening, have you heated it up because you've got a cheaper rate then, or are you heating it up because that's when you've always done it? And look at maybe heating it up a bit closer to the time you're going to use it, if you've got a set pattern of usage. If it's on all the time and you haven't got a lot of hot water usage, obviously if you're using a lot of hot water and you want to constantly keep it full, then having it on all the time might work for you. The thing about all these energy tips is a lot of them can be very specific either to the property or the way you live in them. But if you've got not a lot of hot water usage and you've got a big cylinder, it might, and it's well insulated, it should hold it. You should only lose a few degrees off the top of the temperature during the day. It shouldn't cool down that much, rather than having the immersion kicking in and out, because it shouldn't have a lot to do. But if you just draw a little bit of water off, which just cools it down a bit, and then the immersion warms it back up again, it might be that that little bit of loss is not a problem, because it's still going to be hot enough later on when you go to use a bit more. If you wanted, like with all these things, experiment. Try it one way for a week, try it on and off for a week, and see which uses the most energy, and then go with the most efficient way of doing it in your situation.
Sure. Okay. I've got another question here about electric boiler. I'm not sure if we're going to get very far with this. Rolly has got an Electromax combined electric flow boiler and a direct unvented hot water cylinder. Just that you mentioned efficiencies in gas boilers. Is there anything you can say about efficiently using an electric boiler?
Electric boilers, they would be classed as 100% efficient, because you're not actually burning anything on site, so you've got no losses there as such. To make the most of the boiler, again, what tariff are they on, and can they get a tariff which gives them a cheaper rate at some point when they can do a lot of their heating? Or if it's a boiler that's just running the heating directly all the time, then adjusting the settings, the thermostats as low as possible to make sure that the building stays comfortable, but minimize the amount of heating that it has to do.
Okay, thank you. Back to floors again. Solid floors, what's the best floor covering for uninsulated concrete solid floors? Would you go with the carpet and underlay, or cork tiles, or wooden flooring? Are any of those more insulating than the other?
Again, it depends on what you want. If it's in the living room and you're going to put a carpet down, put a good thermal underlay underneath it. If it's in somewhere like the kitchen or the bathroom, you don't want to put carpet down there, you want to have sort of another flooring surface, then maybe cork tiles would be a bit more efficient than a lino, or put an insulation layer. Again, you can get thin, like 5mm thick insulation layers, you can put that down. You don't want to put too much insulation down on a solid floor, because it then starts impacting on doors. Because if the floor is a lot higher in one room than the other, then you end up not have to take the door off and cut a bit off, which will then reduce the headroom of the door and the knock-on effects. But yeah, it's what you want to do in that particular room. If it's carpeted, you put an underlay in it. If it's tiled floor, you might want to use cork tiles. They're a bit more efficient than putting a lino down, maybe. Wooden floors, if you're putting laminate floor down, you can put some insulation underneath that, thermal lining, or a thin insulation layer underneath the flooring there.
Laminate, yeah, okay. Right, we've got a comment from Keith on secondary glazing. I strongly recommend, from personal experience, the use of Magna Glaze secondary glazing on sash windows. We installed 8 years ago, found it very efficient with no deterioration in the clarity of the high quality polycarbonate panels. Huge improvement on old-fashioned secondary glazing. That would be great in conservation areas and listed buildings where you can't change the windows. There's a video that Jackie's loaded up from a previous talk about boiler temperatures. Is there a way to stop cold water? Sorry, I've lost this. Vanny, is there a way to stop cold water topping up the boiler, immersion boiler? I don't quite.
No, because every time you turn on the tap, it puts cold water into the bottom to keep the cylinder full.
Yes.
If you want to do that, you can get cylinders now which heat from the top down rather than the bottom up. It involves replacing your hot water cylinder, which is it's not a cheap thing to do these days, but it will then, you can then get it to heat from the top down. You can go to thermal stores, which is a whole different subject really for water storage, but these sort of things heat top down. So if you put cold in at the bottom, it doesn't make much of an effect on the temperature of the water at the top. Traditional cylinders, when you turn a tap on, the hot water comes out the top and cold water is thrown in the bottom, which mixes it all up. So you end up with warm water then instead of stratified water that you would do otherwise.
Okay. We're running out of questions now. Just if anybody's got anything else, do throw them in. Ian makes another comment. If you have solar panels and a battery, you can still sell surplus energy back to your supplier, electricity back to your supplier. If you use a lot of electricity, it may be worth topping up the battery from the grid at night when the cost is low. So you have a lot of flexibility, I think, is what Ian is saying with a battery. I mean, that's quite a good deal, isn't it? If you can sell your power when it's expensive and then buy it cheap off the grid in the middle of the night, that's a good way to do it.
Yeah, and there are tariffs out there which have a variable export rate as well. If you've got batteries and PV, you can go onto a tariff which gives you a very high export rate early evening, when electricity is traditionally its most expensive, the big peak.
Yeah.
And so if you've got solar panels, you can get paid for your electricity through the Smart Export Guarantee Scheme, but it's generally not very much, 4 or 5p quite often. Octopus have a standard outgoing one for 15p, which gives you a better return. Or if you're on one of the specific battery and PV systems, then you can get as high as 30p a kilowatt hour in the peak rate. If you've got, in the ideal world, if you've got a southwest facing solar array with a battery, then you're still going to be generating into the peak period. If you've got an east facing array, you're not going to be getting very much generation in the peak period, so it's not going to be as lucrative. Then the next step would be maybe to look at putting a tracker up there, not mounting your panels on your roof if you've got, and especially for people in conservation areas or listed buildings and they're not allowed to put panels on the house itself, they could put them on a tracker in the garden if they've got space, and then they will maximize the output of the panels by following the path of the sun.
Yeah. Okay. Here's a big question to take towards the end about setting up solar PV and having a battery. This is from Susan. I would say actually, initially we did a whole webinar a few months ago on sort of the financial aspects, the return from solar PV and whether it's worth having a battery or not. Gordon Coppock did a very full webinar on that. If you want to look that up on the HGN YouTube channel, I recommend that. So the question is, I'm setting up a 2.2 kilowatt solar PV system and considering fitting a battery storage to this. What advice would you give? I suppose that depends largely on whether you're using the power during the day. Is that a fair comment?
So I'm guessing that they haven't actually installed it yet. They're looking at putting in a 2.2 kilowatt system.
No, I think it's going in, and the question is, should I add a battery to it or not?
Right. Now, if you're putting in a PV system and you put a battery on the system at the same time, then it's zero rated for VAT, which can make a big difference to the price of the battery that you're buying. Also, if it's going in at the same time, you can have a hybrid inverter rather than having the PV with the inverter, which turns it into AC, then having to turn it back into DC to put it in the battery and then turn it back into AC to get it out of the battery again. If you're doing it all at the same time and you have a hybrid inverter, it can go straight from the panels into the battery and then comes out of the inverter. So you've only got one inverter and you've got less conversions going on, and you're paying no VAT on having the battery, but it only applies if you do it at the same time. If you add the battery to an existing solar panel system, then you will be looking at the extra cost and the double inverter situation. But the 2.2 kilowatts is probably not, depending on your household, is not going to give you a lot of surplus generally. Although having the battery there would then allow you to go on to one of these battery and PV time of use tariffs. So the economics would be dependent on what you're doing and how you're using it and what tariff you're on.
Okay. We've got another question here about internal wall insulation. This is a bit of variety for you, Paul. What's the usual depth of internal wall insulation to be installed? Sarah's obviously concerned about how much of the room area is going to be lost if she installs internal wall insulation.
Yeah, obviously it does have an impact on the room, but you only have to insulate the external walls of the room. So it might be that that room only has one external wall, so it might not. Now, as regards the depth of insulation, that's dependent to some extent on what you want to do, what you're trying to achieve, what materials you're using. Because if you've got a solid brick wall and you're using a more natural material, it might have to be a bit thicker than using a man-made material like a foam, for instance. But if it's an older building with solid walls, you probably want to use something that's breathable, so you don't get issues with condensation in behind the insulation. It's a whole other subject on itself, insulating solid walls. We could do a whole hour on that, but as a quick summary,
and we have you can look again. So the HGN team will be sharing the recorded webinars. Again, we covered that much earlier in the year. Right, another question from Vanny. Immersion boilers. I thought if I turn off the mains water, it will stop mixing cold water into the water heater. My bathtub drains it, gravity fed. Would that be dangerous or is it effective at all? I don't entirely follow that. Have you picked some of that up, Paul?
Well, if you turn off the flow to the cylinder, then there'll be no pressure to actually push the water out when you turn on the tap.
Yeah.
Because it's either going to be an unvented system which relies on mains pressure going in at the bottom to push the water out the top, or it's going to be a vented system with a header tank. And if you stop the header tank, then again, the hot water is not going to come out of the taps anymore.
No, you've got no pressure. Yeah, I think the very nature of heating up water is it's cold to begin with, and then it's hot once it's been heated up.
Yeah.
Sorry, that wasn't a very glorious place to finish. Oh, we've got another one from Keith. Am I correct in thinking kingspan insulation used in many new build properties is not breathable? Keith, you're dead right. It is not breathable. Right. Might you mention the recently launched Great British Insulation Scheme? I know we've just been looking for an update on that. It might be that Jem has got something to say about that. I know just to fly the flag for heat pumps, if we're allowed, the boiler upgrade scheme, which was offering £5,000 towards the cost of a new heat pump, has now been increased by 50%, so £7,500 if you're thinking about getting a heat pump. Dear Mr. Sunak has made it more attractive as of the sort of the end of October. I think that's coming in. Before I say anything I haven't fully researched, I'm going to hand back to Jem, and my thanks to Paul. Well done.
Excellent. Thank you very much. Let me just share my screen again. There we go. So yes, thank you very much, Paul. Thank you to everyone for asking all those questions. I thought we'd have heaps, and we did. You delivered. So thank you, audience. Thank you, Tony. Thank you, Paul. Hopefully that 101 guide will also, which will circulate, will also give loads more hints and tips. Right, so just a little bit about what we've got coming up next, which we did touch on some of this. So retrofitting a solid wall home. That is the next webinar that we've got, Monday, the 30th of October. Time is to be confirmed. It will be the lunchtime slot, just not quite sure what part of lunchtime. So we'll let you know about that. But there'll be, yeah, lots of interesting things in there about how to insulate, internal wall insulation for solid walls, and that kind of thing. So hopefully you'll find that interesting. Then we've got how to insulate your roofs, flat and sloping ceilings. Obviously we touched today on, well, a fair bit about loft insulation, how important that is, but what do you do when you haven't got a straightforward loft setup, or you can't access your loft, or you are living in your roof space? What do you do then? Because it's still a really important and often overlooked area. So we'll give you some hints and tips on that. Retrofitting of the Victorian terrace. I'm not sure how many of you with us today are living in one of those, but I'm sure there'll be a few of you, and a lot more. We have a whole series taking us through autumn and into the winter, we'll be here to keep you company as the nights draw in and as you don't want to be outside quite so much. So please keep an eye out. We'll be sharing lots of information about those as we book them in. And if there's a topic that you would really love, let us know. We'll try and put one on. We are here to help you all to improve your homes, make them more comfortable, save energy, save carbon. So help us to help you. What else we got? Ask an expert. So Future Ready Homes, they are supporting best practice retrofit with their team of experts. They've got panel of architects, structural engineers, heritage specialists, and on and on and on. Their website already has a lot of good advice on there, and they've already answered lots of questions, but they want to offer more advice. So if you have any itching questions about how to do something, what materials to use, much like we've been talking about today, whether your home is heat pump ready, now is the time to ask that panel. So please get in contact. Obviously Tony just mentioned about the upgrade to the investment in the boiler upgrade scheme, which I was also going to plug. So yeah, now is a good time to actually start thinking, if you haven't already, about whether heat pump might be right for you. Any other questions, send them in. The most popular ones and that we think are kind of widely applicable go up on the website, so that all of us can learn from each other's questions. It is a good chance that whatever question you have, lots of people will be asking the same one, so ask away. And then if you don't want to ask an expert, ask your neighbours instead. There you go, that was quite smooth, wasn't it? We've got Green Doors coming up next month, which I did mention earlier. It's from the 14th of October for 3 weekends, right the way across Herefordshire, Shropshire and Powys. We love this event, and we love putting it on because the people visiting love it and the people opening their homes love it as well. But what it means is people that have retrofitted their homes in some way, be it a fabric approach, they've upgraded that with internal wall insulation, external wall insulation, double or triple glazing, underfloor insulation, or dug up all of the stone floors. Not too many people doing that, but there are a few. Or they've got solar and battery arrays and switch to air source heat pump. They're opening up so that you can go and ask them questions. You can actually see what it's like living with some of this technology. You can ask them what contractors they used, installers, what they learned from the process, what mistakes they've learned from and that you can benefit from. So go and have a look. We have so many different types of houses, everything from the passive house, new builds, to very old cottages, stone cottages, and everything in between as well. So there will be something there for all. And there are dozens and dozens of them. So there should be one that's nearby as well. Or you could use an excuse to get out for a jolly around the countryside this autumn and go and see a few. I know last year there were a few of Herefordshire people went all over the place and visited everyone they could. So yeah, check that out on the Future Ready Homes website. I think that's about it. If you've got any questions, anything you want to tell us, please get in contact with me on the Building Sense email address. I will be getting back in contact with you shortly anyway with the recording, with Paul's 101 guide from Severn Wye Energy Agency, the backlog of webinars that we've got, so you can check those out, because I know there's quite a few people here today that this is the first webinar of ours that they've attended, so you might want to check that out. And anything else I think is going to be useful to you. And of course, we'll let you know about new webinars as they're planned and as they're booked in. And we'd love to have you along. That is it then. Thanks to all once again. I hope you've all managed to have some lunch. And if you haven't, please go and do that now. And we'll catch up with you next time.
Thank you.
Bye.
Bye.